I want to use implicit differentiation to find the second derivative of x squared plus y squared equals 1. So I'm going to find the derivative with respect to x. So the derivative of x squared would just be 2x. The derivative of y squared is 2y times the derivative of y with respect to x. And the derivative of 1 is just 0. I'm going to move the 2x over. So I have 2y times dy over dx is equal to negative 2x. The 2's are going to cancel. And I'm going to divide by y. So I have dy over dx is equal to negative x over y. I have my first derivative. Now I want to find the second derivative. So I want to take the derivative of negative x over y with respect to x. Here I have to use the quotient rule. So the quotient rule is the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. In this case, the derivative of the top is negative 1, the bottom is y, minus the derivative of the bottom is dy over dx times the top. That's going to be all over the bottom squared. Okay. For the next step, I'm going to make a substitution for dy over dx. So dy over dx is equal to negative x over y. And now we have a negative and a negative, which will be positive. So we have negative y plus, in parentheses, negative x over y times x all over y squared. I'm going to multiply that. So the negative x times x is negative x squared. It's going to be over y, and then everything all over y squared. So going back to the original problem, so we have x squared plus y squared equals 1. That means if I move everything to the right except the x squared, so x squared will be 1 minus y squared. So negative x squared would then be y squared minus 1. So I'm going to replace this. So I'm going to replace the negative x squared with y squared minus 1. So it's y squared minus 1. That's going to be over y. And then the whole thing over y squared. So I can break up the y squared minus 1 over y into two fractions. So you can think of it like y squared over y, and then minus 1 over y. So the y squared over y would just be y. Okay, so we can rewrite this as negative y plus y minus 1 over y all over y squared. The y's are going to cancel. I'm left with negative 1 over y divided by y squared, which is the same thing as multiplying by the reciprocal. And so my final derivative here is negative 1 over y cubed. Okay, next we'll be looking at x to 2/3 plus y to 2/3 equals 1. So I'm still going to be finding the derivative with respect to x, and to be clear, the second derivative. So first we're going to be taking the first derivative, so it's going to be very similar to the previous problem. So whenever I take the derivative of y with respect to x, I always need the dy over dx, and that's going to equal 0, because the derivative of 1 is 0. I have factors of 2/3, so those are gone. I'm going to be left with y to the negative 1/3 times dy over dx, and then we're going to move the x and negative 1/3 to the right, and when I divide both sides by the y to the negative 1/3. I get this. And because I don't like the negative exponents, they're going to, all it does is just move to the bottom or to the top. So the x to the negative 1/3 is going to go to the bottom as a positive, and then y to the negative third is coming up the top as a positive exponent. So something like that. Okay. All right, so that's the first derivative. And if I want, I can factor out the exponent like this. So many ways to represent this. So for the purposes of this problem, I'm just going to leave it in this factored form, so the exponent outside. So now I just want to find the second derivative. So I need to take another derivative of negative y over x to the 1/3 power. And this, I'm going to require the quotient rule. So here, well, what we could do actually, we'll need the quotient rule, but we could use the chain rule first. So we'll bring down the exponent, keep the inside the same, subtract 1 in the exponent, and then take the derivative of the inside. So this one, we can actually, well, the last problem we had negative x over y, so we can't use the previous result. So let's just go over this. So it's always good to start with the bottom squared. And now we're going to have the derivative of the top, which will be negative dy over dx, times the bottom, minus the derivative of the bottom is 1 times the top, so this will just be 1/3. And here I can make the exponent positive by flipping the x and the y. Okay. And so I have negative dy over dx. So dy over dx, if we look, is this thing right here. So this was the first derivative. So we can replace it with negative y over x to the 1/3 power times x, and then plus y over x squared. The two negatives make this positive. Because this is an odd root, so with the odd roots, you can pull out the negative, but either way it's going to be positive. And then we can simplify this further. So this negative here, you're raising it to the second power, then cube rooting it, so that's going to be positive. So I can have 1/3 x over y to the 2/3. Okay, and then I'm going to break up the y to the 1/3. Then I have x to the 1/3 times x. That's just going to be x to the 2/3 plus y over x squared. And now I have this x, let's see, so this x to 2/3 and x squared, that simplifies to x to the, let's see, 4/3 and this y to the 2/3, I can simplify these guys. So what I'm going to do is take this 3 down here, and then I'm going to have y to the 2/3 on the bottom, and then I'm going to have, let's see, pull out a y to the 1/3, so that'll leave me with x to 2/3 times, or plus y to the 2/3. So y to the 1/3, y to the 2/3. So that's going to be y to the 1/3 on the bottom. So I'm left with x to 2/3 plus y to the 2/3 over 3 times x to the 4/3 times y to the 1/3. And that's my derivative.